Hi everyone, just a quick update here. I've just been quickly putting my brushes together here, testing different timings, and I have something interesting that I would like to show now as well. And basically it's an idea that I had over a couple of weeks ago when I first was thinking about how the principle of this would work. And I was quite certain that the rotor flyback would need to be collected and sent back to the stator coil. Now you can't really necessarily do that just by putting a diode because there's a break in the segments of the commutator here. So as soon as that break happens, you lose the flyback. Unless the spark can jump across there, but I kind of doubt that because usually two brushes, the brushes across two segments there. So anyways, I think TK is getting the same kind of idea there. I saw his work, so I decided to push this a bit, and it's probably like 2 or 3 o'clock in the morning now, and show the idea that I have. And what it is I'm using my signal generator. I've got at 900 Hertz with a duty cycle of 50%, and I'm using it to trigger a MOSFET, which what I'm doing is, this is my source here, and this is the voltage, this is the current, and I have a variac and I can just vary the voltage to whatever I want. I'm going to make the connection here. We're going to be powering, we're basically just chopping the DC here at 900 times a second. So what's happening is as the commutator is on top of one segment, the chopping of the DC is turning it on and off many times as it is on one segment. So there you can collect flyback at that time until it jumps over to the next segment and on again. So it's basically going at a higher frequency than the commutator segment's length. And here I have a flyback diode collecting the flyback here, so that's the negative coming here that's being chopped. And so now I'm actually in the direction here to collect the positive, which is going back to one stator coil. And the other end here is on the other side of the brush here. And interestingly enough, what I'm finding is the negative side here of the brush stays cool, and but the positive side here of the brush gets very warm if I raise the voltage. So not quite sure about that. I've got a couple of bulbs here. I'll show you what happens when we put it in series, and then taking off the load and taking off basically the flyback to the stator. The motor just comes to a stall and it wouldn't turn if you don't send the flyback to it. And you'll be able to see exactly how much current there would be trying to make this thing turn just by, sending the duty cycle up higher without the flyback going. I'm going to do all these kinds of things and you'll see the difference. So let's start it up here, and so there you go. It's spinning, and we're at about 12 volt range, about 900 milliamps it's utilizing, and again our frequency is 900 hertz, 50% duty cycle. Now if I reduce the duty cycle, you hear the motor just basically, drop in RPM and pretty well come to a stop. The frequency stays the same, but the duty cycle is so small, and yet it's reflecting also on the current. There you go. And now we'll raise our duty cycle back to 50%. And obviously if we go above 50%, it's going to go faster as well and use more current. So there you go. It's fairly efficient there, and not much to see on the scope shot. I've got my scope probes across the other coil, which is just basically open. I haven't done anything with that, just utilizing one stator coil here. So I have some bulbs here. One bulb is lit right now, and I can disconnect that bulb. Maybe I can place that here. Okay, so now I'll disconnect the bulb. Let's look at the current first. Bulb is disconnected. You hear the motor RPM drop actually, and you're hearing the frequency a little louder. Current is exactly the same. So we're able to power the bulb without having any effect to the motor. And now you can see more activity on the open coil of the other stator coil. And now I'm going to go ahead and attach the bulb back again. The bulb is back on. Exactly the same amount of current, no change. And what I'll do now is I'll put the other bulb here in series. I've got it set up ready. So there it is. Two bulbs now hooked up in series. Pretty well same amount of current, maybe slightly more. I'll disconnect the two bulbs. The bulbs are disconnected. There we go. Bulbs are connected. There we go. And now we'll just disconnect the stator coil. So basically the flyback to the stator coil, I'll just take it off. And it all comes to a stop. That is our frequency of our pulse DC. And now our current is lower though at this point when I disconnect that. But there is no activity at all. And when we have it connected, it's powering the load and it's utilizing this amount, and it's starting to rev back up. And let's notice here we've got 930 milliamps there, and we're going to now disconnect again the stator coil, and we're down to 550 milliamps. What I'll do is I'll raise the duty cycle. So now we're sending the pulses, more energy, and now we're up to 1 amp. 1,120 milliwatts, or 1.12 amps, milliamps, and as you can see, the motor does not turn. So we're at 77% duty cycle. Now I'll just bring it back down. That's just to show you that even though we're sending more current, it won't turn without the stator coil assistance. So now I'm hooking back the stator coil, and as you see, it takes off no problem. The bulbs are lit. So now better RPM, more work to the motor, more output RPM if I put less DC resistance. You hear it now going up in RPM. Now I only have one bulb. Bulb is more lit. So now what I'll do is I'll actually short it. So now the coil is basically shorted. Now it's actually spinning up to its highest potential. And if we look at our open coil activity, that's what we're seeing there. So now what I'll do is I'll reduce the duty cycle. %, duty cycle. The motor is still spinning, and it is only utilizing now 540 milliamps. And if we disconnect this, the flyback to the stator, and we bring it to 540 milliamps, there's no way it'll turn. So there you go. I think this is a good method to be able to utilize the flyback from the rotor coil back into the stator coils. And who knows, maybe that is the combination. And this is just a work in progress. And thanks for watching. Bye now.